Today's lesson is 10.2, Surface Area and Volumes of Pyramids and Cones. A pyramid is what is called a polyhedron. That means it has one polygon base and one vertex. The lateral faces are going to be triangles and they have a common vertex. So if you take a look at our pyramid here, we have a triangle, a right triangle for our base. There is only one. And then our lateral surfaces all meet up here, and you can see the first one right there at the vertex D. Pyramids have what are called a slant height. This is the height of one of the lateral faces, so that one of the heights of the triangles. A base edge is a segment connecting the vertices on the base. And the altitude or the height is the perpendicular distance between the vertex, the base and the vertex. And just a quick reminder that a cone is just a pyramid that has a circular base. All right, here is a better 3D representation of the difference between the slant height. Notice that the slant height here is on your lateral face, the yellow shaded triangle, and the height goes from the vertex of the pyramid down to the center of the base, which in this case is a rectangle or a square. All right, let's go ahead and take a look at some surface area problems. There are two different formulas. There is the lateral surface area and the total surface area. The lateral surface area formula is 1/2 capital P times lowercase l. If we go over and look at our table, LA is for lateral area. The perimeter, just as we saw in the first lesson, P is for the perimeter of the base, but this new variable L is my slant height. For my total surface area, my formula is my lateral area plus capital B. Now, I like to actually write this in this form because remember, Alex normally just asks for the total. And so why do two problems when you already have to do it all in one anyways? So P and L we already talked about. Capital B is my area of my base. And of course, TA at the beginning is my total area. All right, so for example 1 here, they want us to find the total surface area. I'm going to go ahead and highlight that. Total surface area. Remember that if Alex just says find the area, surface area, it always wants the total surface area. I'm going to go ahead and I'm going to write down the formula. And then over to the side, I'm going to take care of P, and I'm going to take care of B. Now they come from the same thing, so I'm going to make them two different shades of purple. I hope you can see that one is lighter and one is darker. And then just because I think it'll stand out more, I'm going to make the slant height in pink, just because I think it'll stand out more. Now notice right here, they've already told me what the slant height is. I'm going to go ahead and I'm going to do the base. Just trying to think if I have a lighter one. All right, here is my base right here. Remember, the base is going to be most of the time in a pyramid at the bottom. And there is only one because notice they meet at a vertex at the top. So it's the one under the vertex. There's my base. So to find the perimeter, I just need to add up the 3 sides. Well, I know it's 3 plus 4, but this side right here, I don't know. Well, it is a right triangle, so I can go ahead and do the Pythagorean theorem to help me solve for this. This is going to be my C. I'm going to put it in black. There we go. And so I'm going to go ahead and say A squared plus B squared equals C squared. Now this is probably the trickiest that you would get on a problem. Most of the things that I have seen in Alex, they have given you what you need, okay? So I went ahead and I squared 3, 3 times 3. I squared 4, 4 times 4, and then I added the 9 and the 16 together. The last thing I need to do is take the square root to get rid of the square. Oops. There we go, that's better. And the square root of 25 is 5. So this side is 5, and I'm going to go ahead and add that to the perimeter. 3 plus 4 plus 5 is 12 centimeters. So now I know what to plug in there. And now the last thing I just need to do is find the area of the base of this triangle. It is 1/2 times the base of the triangle times the height of the triangle. The nice thing is that this is my base and this is my height because C is my hypotenuse per the Pythagorean theorem. So it's 1/2 times 3 times 4, which gives me 6 centimeters squared. Now I have everything I need to go ahead and plug into my formula. For the perimeter, I'm going to plug in 12. For the slant height, I'm going to plug in 7 because that's what it said over there. That's what it said right here. And then I'm going to go ahead and add in the area of my base, or sorry, the base of my area. The area of my base. I said it right the first time. There we go. I'm going to go ahead and put this into Desmos. I can put it in exactly how it looks, or I can do it piece by piece. If I do it piece by piece, I have 42 plus 6, which gives me 48. My unit, centimeters squared, because we're doing area. All right, let's take a look at another one. Notice once again that they have gone ahead and given me the slant height. There's no reason for me to find it. My base is going to be this rectangle. No, I'm sorry, this square on the bottom. My base this time is a square. That's nice. Which means to find its perimeter, I'm just going to say 12 plus 12 plus 12 plus 12. Or I could have said 12 times 4. And for the area, it's going to be base times height, 12 times 12, 144 centimeters squared. My formula for the total surface area is exactly the same, 1/2 the perimeter times the slant height plus the area of the base. I'm going to just go ahead and color these in so that I can put the right numbers in the right spots. That's why I love the colors so much. It really makes my math easier. And I know sometimes math can seem very, very hard. And so anything that can help me get rid of that anxiety and that thinking that I just can't do it really helps me out. I can go straight to Desmos now and go ahead and put this in the calculator. You can do it one at a time. So the first part, 1/2 times 48 times 15 gives you 360. Then you can add the 144 to that and you get 504 centimeters squared because we're talking about area. All right, next is volume. The volume of a pyramid or a cone has this formula, 1/3 B times capital H. Now, the B, once again, stands for the area of the base, but this H, ooh, I have to pick a different color. Which one should I pick? How about green? This H is the height of my pyramid or my cone. This is not the slant height. This is the height from the vertex down to the middle of the base. All right, here we go. So let's find the volume. Let's find the volume. Let's put our formula. And let's go ahead and let's find the area of the base and the height. Now, most of the times the height is probably going to be given to you in the picture. At worst, you might have to use the Pythagorean theorem to find it. But this right here is going to be my height. This right here is going to be my height. To find the area of my base, I need to know what my base is. Well, my base is going to be this regular polygon. Oh. And as I drew it, it had 6 sides, so it is a hexagon. And to find the base, I have to use this formula. Now, the apothem is this one right here, and this is the side. This is the side. This is going to help me find my perimeter. To do my perimeter, if you remember, it's the number of sides, 6, times how long each side is, which gives me 24. And of course it is centimeters, but that's okay. So it's 1/2 times 2 square roots of 3 times 24. Now, Alex might have you do a decimal. It might not. I'm going to go ahead and leave the square root of 3 like it was a variable. And I'm going to say that the area would be 24, 1/2 times 2 times 24. So I just did 1/2 times 2 times 24. I left the square root of 3 and I just put it in the answer. All right, I have everything I need. Let's go ahead and plug it into the volume formula. I always forget that it changes from 1/2 to 1/3. That's why I always write down the formula. It helps me, and then I catch it when I do something like what I just did. All right, there we go. And I'm going to go ahead and put this in my calculator. Now, it just depends on what Alex says. Alex could say leave it in terms, leave it in simplest radical terms. That would mean all that you're putting in is the 1/3 times the 24 times the 6, which gives you 48. And you just put the square root of 3 after it. Centimeters cubed because we're talking volume, or you could just go ahead and put the whole thing in the calculator and it'll give you a decimal answer. It just depends on what Alex asks for. All right, let's take a look at one with a cone because more than likely this is what Alex is going to ask you, and it's not going to do the regular polygons. It's going to stick with the rectangle and it's going to stick with the triangle. So you'll be able to have a base area that is a whole number. But let's go ahead and do this one. There we go. It's the same formula. My base, though, is a circle. So my base is a circle. And the area of my base is pi times the radius squared. Now I have two options at this point. I could actually take that capital B in the formula and change it to pi r squared. So I could actually say, well, it's 1/2, or sorry, 1/3. See, I always think 1/2 and then I have to change it, times pi r squared times the height of the cone. You could actually think of the formula in this terms. It's totally up to you. This right here would be my height. This right here would be my height because it's going from the vertex at the top down to the center of your cone. Here is my radius. So either way, I could put it in either way. It doesn't matter. Now, what I would probably do, in all honesty, is I would leave pi until the very end. Okay? Because if Alex asks you to use 3.14, this is where you'd want to use it. So this is where I would put, so I would change it to that. Oh, can you see that? Let me see. Let me make that 9 a little nicer. There we go. I would change it to this. So in my calculator, I would put 1/3 times 9 times 3.14, and I would come up with an answer and it would be centimeters cubed. Okay, I do believe from what I've seen in Alex, they do ask you to use 3.14. Now, I do want to show you the surface area question that they are going to ask you about the pyramids because it does look a little bit different in Alex. So here is a triangular pyramid and it's net. That just means that they've taken the pyramid and they've unfolded it at the vertex. The lateral faces are congruent triangles, so that means all of the triangles are the same. And the base, the shaded region, is an equilateral triangle. I'm going to have to remember that. So I'm going to go ahead and highlight that. That means all the sides of my base triangle are exactly the same. So let's go ahead and look down here. I'm going to go ahead and put that all of these are 3. And I'm actually going to go ahead and draw them in, darken them in on the base, just so that I remember. Okay, they're going to ask you to do 4 questions. The first one is to find the area of the base of the pyramid. The base is that triangle that I just highlighted. So the area formula for the triangle is 1/2 times its base times its height. Looking at that triangle, its base is going to be the 3. This is going to be the triangle's base, and its height is going to be this right here, 2.6. Okay, I'm going to put that into Desmos, and I'm going to get 3.9 inches squared. The area of one of the lateral faces of the triangle, of the pyramid, sorry, of the pyramid. Let me grab the color. It wants to know the area of one of these triangles. So once again, I'm using that same formula, 1/2 the base times the height. This would be the base, this would be the height. So it's 1/2 times 3 times 2, which gives me 3 inches squared. Now the next question is asking me to find the lateral surface area. Please make sure you read when you're doing this one because this section is the one section where it does ask you to do the lateral versus the total. If you look ahead to part D, it's going to ask you to do the total as well. It's going to ask you to do the total surface area down there. All right, so if I go back and I look at my formula for the lateral surface area, it's 1/2 times the perimeter times the slant height. Well, the perimeter that they're talking about is the perimeter of the base, 3 plus 3 plus 3, which is 9, right? Yes. And the 2 right here that I've labeled as the small h, this is actually your slant height as well. This is my slant height right here. So it's 1/2 times 9 times 2, which is 9 inches squared. Now, what you could have done as well as said, well, the area of one of the lateral faces is 3, and there are 1, 2, 3 lateral faces. 3 times 3 equals 9. That will work as well. Okay, just make sure you find once you find the area of 1, you have to count up how many there are folded out of the base, okay? All right, the total surface area, oops, hold on a sec, is 1/2, okay, plus the area of the base. You have all this information already. You already know that 1/2 times P times L, oops, there we go. 1/2 times P times L is this number right here, so that's where the 9 came from. And look at this, you already have the area of the base. It's right there. You already have the area of the base, it's right there, which equals 12.9 inches squared. Hope that helps, guys.